So what if meaning actually has a shape? I know, it sounds a little out there. We're so used to hearing about AI in terms of, algorithms and attention mechanisms, but today we're going to explore a pretty radical new idea, that real understanding isn't a number in a spreadsheet, but a geometry, a tangible structure. Let's get into it.
This quote right here just nails it. It perfectly captures this feeling that's been growing in the AI world. For years, the whole story has been about attention. But what if attention is just the steering wheel? It's useful for pointing you in the right direction, but it tells you absolutely nothing about the road you're on or the landscape you're actually driving through.
All right, so our first step here is to look past attention as the be-all and end-all of AI. We're going to try and see what might be hiding just underneath the surface. And here's the fundamental difference, right? Attention is basically a steering mechanism. It's fantastic at telling a model which words in a sentence should pay attention to each other. But geometry, well, geometry is proposing something way more profound. It's trying to describe what meaning is. It's the difference between just navigating a map and actually understanding the world the map represents. Okay, this brings us to the core concept, the big idea. Meaning isn't just a list of scores or weights. It's a rich, complex, geometric structure. It has a shape. This is really the key shift in thinking we need to make. The old way of doing things viewed meaning as just a single point in some high-dimensional space, basically a long list of numbers. But this new geometric view sees meaning as a posture. And a posture isn't a point, right? It's an arrangement, a stance, an orientation that holds a bunch of different relationships together all at once. It's just a much richer, more dynamic way to think about it.
All right, so a great test for any new theory of meaning is ambiguity. When a single sentence can mean two totally different things. How does this whole posture idea hold up? Let's use this classic example. The doctor treated the patient with a drug. So what does that mean? Did the doctor use the drug as a tool for the treatment? Or was it the patient who possessed the drug? Both are perfectly valid readings locked inside this one simple sentence. And this is where the two views just completely split. An attention-based model treats this like a competition. The two meanings basically fight it out, and one has to win. But the geometric view is so much more elegant. The two interpretations are just different postures that happen to be very, very close to each other in this landscape of meaning. Ambiguity isn't a conflict we have to solve by force. It's just proximity.
So, if meanings are postures, and they can be close to each other or far apart, then they have to exist somewhere. Let's talk about this semantic landscape.
What is this world really? What's the actual, mathematical space where all these different shapes of meaning can live and interact with each other?
Well, the answer is a pretty wild concept called a Grassmann manifold. Now, don't worry about the name, seriously. The key idea behind it is actually simple and really powerful. In this space, every single point isn't a number. It's an entire pattern of relationships, a whole meaning posture, or what a mathematician would call a subspace. Honestly, this is the best way to think about it. Imagine a huge, sprawling map that contains every possible posture or stance that meaning could ever take. That's the Grassmann manifold. It's the entire universe of all potential meanings. Okay, so if meaning is a shape and it lives in a landscape, then what is thinking? Well, this geometric idea completely reimagines what it means to reason about something. So let's rethink what a transformer is actually doing. A sentence comes in, and it sets up an initial posture in this landscape. Then each layer of the model doesn't just calculate something, it gives that posture a little nudge, a slight rotation. The whole thing is like a journey, a walk through this semantic landscape, one step at a time, until a new final posture emerges at the end. That's your output. Which brings us back to attention. See, in this geometric world, attention isn't the engine anymore. It's more like the dashboard, the instrumentation. It gives you the handles, the local controls you need to guide each little rotation. But it's the geometry itself, the landscape, that actually holds all the meaning. This changes everything about how we define reasoning. It stops being about following some set of symbolic rules, like you're building a logical proof. Instead, reasoning becomes movement. A good, solid chain of thought is just a smooth, efficient path, a trajectory from one meaning posture to another. Now, this is where the whole idea gets really, really mind-bending, because this model of intelligence as movement through a constrained landscape, it doesn't just sound like math anymore. It sounds an awful lot like biology. And the analogy is just shockingly strong. Think about it. In this view, tokens are like genes. They're the basic building blocks. The context of the sentence is like the epigenetic landscape that decides which genes get turned on or off. A specific meaning, our posture, is like the current state of a biological cell. And reasoning, that path through the landscape, is exactly like the developmental trajectory a cell follows as it grows into a specific type. So here's the big takeaway. Intelligence might not be about processing information, not in the abstract bits and bytes way we usually think about it. It might be the very same fundamental process we see in all of biology, creating and protecting these little pockets of order, these low entropy structures of meaning, using the built-in constraints of geometry.
Okay, so this is a really cool, fascinating theory, but what does it actually change? I mean, what are the real-world implications of looking at AI through this geometric lens?
Well, it changes almost everything. All of a sudden, trying to understand how a model works isn't about tracing billions of individual weights anymore. It's about analyzing the geometric path its reasoning took. The goal of training an AI is no longer just tweaking numbers, it's about literally sculpting the shape of the semantic landscape itself. The whole question shifts from which weight did what to what was the journey of this idea.
If you take away only one single thing from this, let it be this right here. Meaning isn't something that's stored and it's not something that's computed. Meaning is the shape of relationships, a dynamic form that evolves and moves based on the constraints of its world. I just love this quote. It's such a perfect way to put it. For the last few years, we've been completely fascinated with the doorway, with the attention mechanism that led us into this incredible new world of AI. But now we're starting to realize the real discovery wasn't the door at all. It's the entire house that was waiting for us on the other side.
And that leaves us with this final, really powerful thought: semantic morphogenesis. Now, morphogenesis is the biological process that causes a living thing to develop its shape, how an embryo becomes an animal. This suggests that intelligence isn't something we build, like a machine. It's something we grow, like an organism. And that is a very profound idea to chew on. Thanks for joining me.